All right, if you remember, the trapezoid was in its own separate little family in between the parallelogram and the kite because it didn't have two, it didn't have zero, it had one and only one pair of opposite sides parallel. All right, so that is just a trapezoid. And I have no more properties for you. That's it. It's got one pair of opposite sides parallel for a trapezoid. Our focus today is going to be on the souped up version. All right, version 2.0, which is the isosceles trapezoid. Not only does it have opposite sides parallel, if you want to draw yourself one, not only are the opposite sides parallel and one pair is parallel in an isosceles trapezoid, but the other two sides that are non-parallel, they are congruent to each other, and they are called the legs. Okay, the congruent sides are called the legs. And if you're wondering, the base, yeah, I just gave it away, perfect. The parallel sides are called the bases. Two properties I'd like you to be aware of for the isosceles trapezoid. Ready? Base angles are congruent. Base angles are congruent. Now, I know many of you, no big deal. We'll just go ahead and do this right now. Yes, these two bottom ones are congruent. But there are another pair of base angles, which are the top ones. Okay, they are congruent to each other. Okay, base angles are congruent. The bottom two and the top two. And the final property of the isosceles trapezoid, diagonals. Diagonals are congruent. Whoa, calm down. Yep, go ahead and recycle it. All right, just totally disappeared. Good start. Okay, going back. All right, here we go. Base angles, congruent. Diagonals, congruent. Let me just put some letters on this one. So in our case, diagonal BD. Oh, here we go. Diagonal BD would be congruent to diagonal AC. All right. Base angles congruent, diagonals congruent as well. All good. Calculators ready to roll. Okay, here we go. Couple algebra, couple proofs. Find the value of the variables in each isosceles trapezoid. Number one, not too bad. I threw an extra side length in there for you just to see if it would mess with you or not. One equation you can set up right now to solve for x. One equation. 99. Starts off 22. 3x minus 3 equals x plus 5. Legs are congruent in an isosceles trapezoid. Quick solve for x here when you're ready. Here we go. 6 when you're ready. Quick solve for x. 4. No issues. We all good. Okay, let's slow it down here now for number 2. Let's slow it down a little bit. All right, we know what about the base angles? They're congruent. So I know the 6x plus 20 and the y are congruent, but I don't want to set them equal because that doesn't get me anywhere. And I know if that's 4x, but that still doesn't get me anywhere because I still got that darn y in there. So I can't add them up and set them equal to 360. So, and I didn't want to add this extra property in because you have so many already to remember, but let's take a look here. I know the base angles are congruent, but what about these consecutive ones on the side here? Supplementary. Everyone see that? But not consecutive all around, no. But these ones on the side are supplementary. Also, if you forget that, take a look. Whoa, wait, little review. If these lines are parallel, what did we call these angles in the parallel line unit? Same side, interior, and they were supplementary. So I can go back to this problem right here and say, okay, now 6x plus 20 plus the 4x, that'll be equal to 180. Everyone see where we're going there? Okay, value of x out of that one. Number 1, value of x. 16. Okay, whoa, I don't know where everyone's going because we got 2 variables to solve for. Just doesn't say find x, just find all variables. Okay, so thoughts on how I can get to y now? What do you got for me? 8?
So we could substitute 16 in for x in 6x plus 20.
Yes, we can.
And then set that equal to y.
Yep, because what do I know about those 2 angles up there? Everyone agree that y is equal to whatever 6x plus 20 is? So I can say y is equal to 6 times 16 plus 20. When you're ready, the value of y. Here we go, 20, the value of y when you're ready. 116, yes. All righty. Whew, all right. I don't want to say much on this one. Find the value of x. Well, at least I can fill out if that leg is 13, other leg has to be 13, right? Oof, I almost could perform what on this right triangle? Almost. If I knew this little portion right there, could do Pythag. Can we find that little portion so I can do it? Okay. And this 34 represents the whole base length. 24 represents the whole base length. Quick question, little vocab review. Do you remember what this was called if it was in a triangle? Vertice perpendicularly opposite side? It's also called an altitude in the trapezoid. All right, as long as it starts from a vertice and is perpendicular to the opposite side. Could you draw another altitude in here? Yeah, ready everyone? Let's draw the other altitude in. And look what you end up forming. A rectangle in the middle. 2 right triangles that are congruent on the outside. Why is that helpful now? 24, what's the opposite side of this rectangle I just created? 24, how much is left over? 10 to divide up evenly between. Yeah, thanks. I knew that. Thanks. To divide up evenly into these two triangles. So yes, 5 and 5. Now can we do Pythagorean theorem? X squared plus 5 squared equals 13 squared. When you're ready, 15 whenever you're ready, a value of x.
12.
Thank you. We all good there? Go ahead, feel free. Drop down both altitudes, draw in both altitudes, and you form a rectangle with two congruent triangles on the end. Anything right now, because we're getting nuts now. It's going to get a little nuts as we head into the proofs. All right, here we go. All righty. First proof. Prove it is an isosceles trapezoid. And you'll see up above, I've given you, there's only two ways to do it. Either way we choose, everyone read number 1 and 2 real quick to prove an isosceles trapezoid. No matter which method we choose, we still have to prove it a what first? Still got to show it a regular trapezoid. And what's the only property of a trapezoid that we know of? One pair of opposite sides parallel. So that's what we need to do first. Forget about the whole isosceles part. Let's get A, B, C, D, one pair of opposite sides parallel somehow. Can you do that for me? So we know AECD is a parallelogram. Maybe that'll help us out. And two angles are equal down here. Can you get me a pair of opposite sides parallel in ABCD? Can we do that? I hope so. We can use this parallelogram to our advantage to do that. What do we know about DC and A? What is that? AE right now. DC and AE are parallel. Why are those two segments parallel? 25. Why?
Parallelogram implies opposite sides.
Darn right they do. Parallelogram implies opposite sides parallel. How can we use that to get the trapezoid sides parallel now? Take AE and extend it out to B. Yep. So now we can say DC is parallel to AB. Extensions of parallel lines are parallel. Don't try to get ahead of me because you're going to, I didn't mention it, this part yet. Extensions of parallel lines are parallel. It's not a trapezoid yet. Wait a second. You said if I got parallel lines that it's a trapezoid. Not yet. You want to read up here for me? We got to do one more thing. If one pair of opposite sides are parallel, did we do that? Check. And the other pair are not parallel. No. We're not going to have to go indirect here. All right. So we need to at least state, yeah, I got one pair of parallel sides, but now we got to show that DA and CB are not parallel. And this is probably the worst moment for me of the year because it's one of the most non-mathematical things I'm going to have you write down. All right. Here's why. Ready? So does everybody see? Yeah, the parallel sides are good, but you got to get me the other pair not parallel to prove a trapezoid. We're good? Okay. So right now we are going to say that DA, and you can just say not a parallel sign with the slash through it, not parallel to CB. Oh, I'm cringing already. What do you guys know about parallel lines? Intersect, right? If I kept extending DA and CB, what's going to happen? Okay, so we are going to write down they will eventually intersect. The most unmathematical thing you'll write down for me. Don't even try it, Emma. They will eventually intersect. Why don't we all settle down? All right, how about that? All right. So that's what's going to happen. All right. We all good? Okay, now what do I have? Now you could say it's a trapezoid. Once you have the parallel and non-parallel sides, ABCD is a trapezoid. Come on. No, not yet. Not yet. And I already heard it. Yep, you guys can be the funny kids. ABCD is a trap. Ah, it's a trap. Yep, great. Yep. Who brought the cool kid to class? Ready? Why? Ready? What do we have right now? We have one pair of opposite sides parallel. Is that good enough to write? No. And one pair not parallel implies a trapezoid. Okay? You have to prove the non-parallel sides. Non-parallel sides intersecting. You have to prove that. What's up? Yes. Or no, but actually, if they do intersect, write the point where they do intersect. They intersect at point G. All right, so actually write down where they would intersect. All right, now how do I make it into isosceles? I got two options. Prove the legs congruent. Prove a pair of base angles congruent. Once it's a trapezoid. Yes, Roman. Oh, you're going to get me there now. Okay, hold on one sec. Everyone see our options right now. Get the legs congruent or get a pair of base angles congruent, which I believe both could happen here. You could do either one. Where are you going here, Roman? Okay, you go do that. Okay. Yep, everyone see DA congruent to CE. Parallelogram implies opposite sides congruent. Where's he going with that? Where's he going with that? He's got these two, but he needs DA and CB to be congruent here. Building off, Maggie?
Well, we know that CB is congruent to EC because in a triangle, opposite sides are.
There, look at all these darn theorems coming back. CB. Yep, congruent to, what do we have? AD? Nope, not yet. CE in a triangle. Congruent sides across from congruent angles. And then how do I get step 6 and 7 to make DA and CB equal? Substitution. And now, what do you know about this trapezoid? It is isosceles, yep. So ABCD is an isosceles trapezoid. Got a good reason for me? Just don't say legs are congruent. What did you prove it? Remember, what did you prove it first? So trapezoid with what? Legs congruent implies a isosceles trapezoid. And of course, we are in what class here. Yep. How could I have gotten the base angles congruent? How could I have gotten angle A congruent to angle B? Hi, Emma. Everyone right here, everyone see A and this angle right here, they're corresponding. Lines are parallel, that means they're congruent. And then these two are already congruent, so I would say what to get these two? Substitution. Okay, so that's how you could have gotten the base angles. All good. You want another one? Yes, of course you can. There you go, next one. Now I'm going to give you its isosceles trapezoid. You know what, I think talk it over in your group here. I think you guys could handle this one if you talk it over with some people. Maybe find a pair of triangles first. Maybe find a pair of triangles that contain those angles. Okay, I just want to hear different thoughts about what we did here. Because you could prove a bunch of triangles congruent, I think. Did everyone prove triangles congruent or no? Is there a different?
Yes.
Okay, so you either proved the bottom overlapping ones or the top ones. So you either proved these two overlapping ones right here, DAB and CAB, or these two up here, DAC and CDB. Which one was the majority here? The bottom ones here? This one right here? With that one right there? Okay, I already gave you a pair of sides then. What else did you have in those two triangles? Vincent, what's one other thing you had? It shared side AB. All right, definitely shared side AB, reflexive. And then to get to the third pair of sides or angles, hopefully you used a property of an isosceles trapezoid. Al? I wouldn't accept that. There's multiple angle A's in that diagram. Angle DAB congruent to angle CBA. Did anybody use the diagonals instead? Diagonals are congruent. So that could have been side, side, side if you did it that way. My reason here, isosceles trapezoid implies, what property did Al just apply? Base angles congruent. Then you have your triangles congruent. Triangle DAB congruent to triangle DBA, CAB. And what method here would be this one? Side, angle side. And then we finish it off with our old school CPCTC. All right. Not too bad. Anything you want to ask? And of course, couldn't do proofs without proving it on a graph. Quick talk, everybody. It says just prove it a trapezoid. So what are we going to have to do? Prove one pair of sides parallel, but remember, that's not good enough in our proof. We have to prove the other pair not parallel. Do not forget about that. One pair of parallel sides not going to cut it. All right, so what formula is going to be definitely needed here? Slope, slope, slope. And yes, we are going to have to find the slope of all four sides. AB, DC, the slope of AD, and the slope of BC. So I will give you a couple minutes here to go ahead and find those slopes and see if we all agree here. Because you do have to prove the other two not parallel. Let's start it off. We don't have a 30, do we? Do we? Oh, pizza. What do you got for me? You got any of the slopes?
AB is 1/2.
1/2? We agree? Or do we want to boo that one? 1/2? 2. Got another slope for me. AB. DC is 1/2. Perfect. I like that because that means something. Any other slopes you want to give me here? Let's go. 15. Any other slopes? -5/2. How's that look, everybody? Yes, no? Okay, and then what about BC? Anybody got the slope of BC for me? 11? What do we have? -1/2. How's that look? We are right there. Okay, so what did we learn here? Because we can put a couple things that we just learned. What did we learn about AB and DC? They're parallel. So AB parallel to DC. Because, why is that true? Slopes are equal. And what else did we learn? I don't think we learned when they were congruent there, tough guy. They are not, AD is not parallel to BC because slopes are different. Got to have that step in there that they're not parallel. And now what is ABCD? Is a trapezoid. Okay, just so I know, because this one's pretty wordy, just to make sure we got all the right parts in there. Oh boy, number 9, you ready? Why? Take your time. What do I have? Why is it a trapezoid?
Because you have a pair of opposite sides parallel and another pair of opposite sides.
Nice job. One pair of opposite sides parallel, and the other pair is not. Whew. All good. Okay, I don't think there's much there, right, Colin? A couple true falses there I threw in there on you. And 2 quick proofs, it looks like. Here you go. Hey, everyone, take a look at the last proof, number 11. This is answering Vincent's question he had earlier. Keep it there for me so I can read it. See how you're going to prove ABCDs on isosceles trapezoid? So you have to prove it a trapezoid first. And the reason for DA not being parallel to BC is because it eventually intersects, because it intersects at E. So that's what you can put as your reason. All right, intersects at E. All right, go ahead, use this time up.